Probably you're wondering how is it possible to understand calculus in less than 5 minutes. When you come across such an expression, many students just imagine that this is a weird expression and they never know where it came from. I want to start from the basics. When we want to find the area of basic figures, for example a triangle, it is easy. When we have this as the base b and this as the height h, then to get the area, we basically use this formula. Area is given by a half multiplied by base multiplied by height. Assuming that our base is 2 and our height is 3, then we can get the area of this triangle. What we need to do is to plug these values in this formula. A half multiplied by 2, that is 1. So we get the area as 3 square units. And this is basically the area of this triangle. We can also get the area of a rectangle using length multiplied by width, or the area of a circle using this formula pi r squared. Now this is possible because all of these figures have these as their formulas. What if you have a figure that doesn't have a formula to calculate its area? For instance, a curve. And we shall consider this curve y is equal to x cubed. How can you get the area of this? It's very simple. The first thing, you shall just draw some smaller rectangles in the entire region covered by the curve. Then we pick one of the rectangles, for instance this first rectangle. Then this dimension is normally the width, and since this is the width, then the whole of this longer part will be the length. Now, having these two, how do we get the area? The area shall be length multiplied by the width. Let's assume that this width is 0.4. This means that this first one shall be 0.4, then this next one shall be 0.8, this shall be 0.12, and we keep adding 0.4 until we get to this final one, of which it shall be 4. So this basically means that our width is 0.4 for this first one. But what will be the length for this? Notice that we don't have y values, but we have y being equal to x cubed. So this means that we shall have this as 0.4 cubed or 0.064. So to find the area, we just plug these values in this formula and find the area of this first one. And we use the same method for all the remaining rectangles, then we shall sum up the areas. But that is a lot of work. And that is where calculus steps in. And it steps in to reduce your workload. Now we can represent this as x cubed multiplied by dx. Remember, x cubed is our length, then dx is our smallest width. Remember, we are adding these small areas from x is equal to 0 basically at this point. So this we shall have here 0, then up to the maximum point, which is 4. Now what we do next is to replace this summation sign with an integral sign. This sign basically tells us that we are supposed to integrate this function x cubed with respect to dx from 0 to 4. Now how do we perform integration? It is very simple. If we have the integral of x to the power of n and we need to integrate this with respect to dx, then what we do is we rewrite this x to the power of n, then we add 1 to the power, that gives us n plus 1 as our new power. So the same n plus 1, we divide it with the all of this one. So it shall be x to the power of n plus 1 divided by n plus 1. And this is basically how integration is performed. So let us consider x to the power of 3. So the first thing, we rewrite this as x to the power of 3, then we add 1 and 3 plus 1, that is basically 4. Then we divide all of this with the result, which is 4. So this implies that the integral of x to the power of 3 with respect to dx is actually x to the 4th divided by 4. So then what we shall do, we subtract x to the power of 4 over 4 from x to the power of 4 over 4. Then for this first x, we replace it with this number at the top, which is 4. Then for this second x, we replace with the number at the bottom, which is 0. So we begin with this, so we replace here with 0. 0 to the power of 4 is actually 0. So we shall have 0 divided by 4, and that is basically 0. Then 4 to the power of 4 is the same as 4 multiplied by 4 to the power of 3. 4 and 4 will cancel, and we shall be left with 4 to the power of 3. 4 to the power of 3 is the same as 4 multiplied by 4 multiplied by 4, or 64. 64 minus 0, that is basically 64. And hence the area under this curve is actually 64 square units. And we have the final answer for this. So this is basically how integration can help us simplify this workload. So these are the simple steps that you can take to solve for the area under the curves. Hopefully you've understood this concept. Please go ahead and like this video, comment, share, and don't forget to subscribe to this channel. Thank you for watching this video.